Good evening. In today's session, we will see the assertion reason questions on motion in a straight line. Okay, so let us go to the paper straight away. You have to read the directions first. In all such questions, assertion reason questions, the directions can be different on different papers. And you have to ensure that you have read the directions properly before you proceed to the questions. Okay, so let us read option A, directions. In the following questions, take the paper, please. In the following questions, a statement of assertion is followed by a statement of reason. Mark the correct choice as option A, if both assertion and reason are true, and reason is the correct explanation for assertion. Okay, so you have to mark A if assertion and reason are correct. Yeah, the paper with watermark. Assertion and reason are correct, and reason is the correct explanation for assertion. Option B, if both assertion and reason are true, and then reason is not the correct explanation for assertion. Both are correct, but reason is not the correct explanation. So you have to mark option B in such cases. C, if assertion is true, but reason is false. D, if both assertion and reason are false. There can be an E option if assertion is false and reason is true. Okay. Anyway, they have given only 4 options. So let us go to first question now. Frame of reference, distance and displacement. Based on it, you have 2 questions here. Assertion, magnitude of displacement for a course of motion may be 0. Magnitude of displacement for a course of motion may be 0. All right. And statement, reason statement is what? The path length for the corresponding motion is 0. All right. Path length for the corresponding course of motion is 0. The magnitude of displacement for a course of motion may be 0. Right. Tell me, is that correct or not? Magnitude of displacement. Look at this. I have a body starting from A. The body goes all the way to B. Okay. And then it comes back to A. What is displacement? Displacement. He is back at the origin. So displacement is 0. Correct? Right. Just imagine you're going for vacations to India and you're coming back after vacations. So where were you before the vacations? The vacation started, you were in Qatar, and even after vacations, you still remain in Qatar. That means your displacement is 0. All right. Or you just imagine you're going to school. In the evening, you come back home. What is your displacement? 0. Right. So, if a body goes from A to B and returns to A, you can say that the displacement is 0. Let us see the question here. The magnitude of displacement for a course of motion may be 0. Magnitude of displacement. This is displacement, right? So what is magnitude of displacement? That is also 0. Right. So assertion statement is true. Magnitude of displacement is 0. What about reason statement? The path length for the corresponding course of motion is 0. Is the path length 0? No. Just imagine this is 5 kilometers and it is coming back for another 5 kilometers, right? So total path length is how much? Is that 0? Path length is actually 10 kilometers, right? 10 kilometers, which is not 0. So reason is false. Assertion is true. Reason is false. Answer is option C. I'll explain it again. Did you understand? So let's do that question one more time. Question number 1. Assertion. Magnitude of displacement for a course of motion may be 0. Magnitude of displacement for a course of motion may be 0. Look at this. A body is starting from A. It is going to B. It travels a distance of say 5 kilometers and then it is coming back for a distance of 5 kilometers. So what is the displacement? Like I told you, displacement is what? Displacement is 0 because it started from A and it has ended up at A, which means, it is the initial point and final point are the same. So displacement is 0. If displacement is 0, magnitude of displacement is also 0 because 0 is without sign. So even if you take magnitude, you're going to get 0. So displacement, this is what they say in assertion statement. Read assertion statement. The magnitude of displacement for a course of motion may be 0. Right, that's true. That's true. Reason, the path length for the corresponding course of motion is 0. Is the path length 0? No. Path length to the right is 5. Path length to the left is 5. No. So path length is how much? Total path length is how much? 5 to the right plus 5 to the left. So 5 plus 5 is 10 kilometers. Is that 0? No, path length is not 0. They say it is 0. So assertion is true, reason is actually false. So if assertion is true, reason is false, you have to choose option C. Is that clear now? Now moving on to question number 2, assertion. In one-dimensional motion of an object, path length comes out to be equal to displacement. One-dimensional motion of an object, path length comes out to be equal to displacement. Path length is actually another word for distance travel. Path length, okay? Path length comes out to be equal to displacement. So in one-dimensional motion, look at this. This is one-dimensional motion. One dimension means straight line motion. Look at this one-dimensional motion. Say, imagine it is traveling 4 meters, then another 3 meters. It is going from A to B first, and then B to C. Look at that. The body is traveling from A to B, then B to C. Question number 2. In one-dimensional motion, this is called one-dimensional motion, and then path length comes out to be equal to displacement. What is displacement here? Displacement is the straight line distance, correct? Displacement is straight line distance between initial and final points. Displacement is 4 plus 3, that is equal to 7 meters. What about distance? Distance is also 4 plus 3, that is equal to 7 meters. So in one-dimensional motion, distance and displacement are equal. We have seen this in class. So read it again. Assertion statement again, then reason statement, okay? Assertion statement says what? In one-dimensional motion of an object, path length comes out to be equal to displacement. Path length means distance is equal to 4 plus. They are equal as per assertion statement, so that is true. All right. What about reason? That the direction of object is changed 2 times. Is the direction changed? No, it keeps moving in the same direction. Then only this is valid. So reason statement is false. Read the statement once again. You know, direction of object is changed 2 times. No, direction is never changed. It is one-dimensional motion. It keeps moving in the same direction. Then only this will work. So assertion is true, reason is false. Answer is option C. Did you understand? Now, before moving to the next question, I'll tell you one more thing. What if it is not one-dimensional motion? Look at this. You know, the body is moving in a straight line like this from A to B. Then instead of moving in straight line, it moves like this to C, 3 meters. Look at that. This is 4, this is 3. What is the distance travel? 4 plus 3, 7. What is the displacement? This is Pythagoras theorem, no? That gives you 5. Correct. Are the distance and displacement equal here? No. Look at this. You know, that is a straight line motion. That is one-dimensional motion. There is no change in direction. There is no deviation in the path. On the other hand, if there is a deviation in path like this, the body travels in a straight line. Look at that. From A to B. A to B, it travels in a straight line. Then what? 4 meters. Another 3 meters here. Tell me the total distance traveled is 4 plus 3, 7. And what is displacement? Displacement is 5. Pythagoras theorem. Root of 4 square plus 3 square. 5. So here if you take distance will be 4 plus 3, 7. And displacement will be 5. Obviously, distance is greater. And we have even written the statement. Hope you remember. Distance is greater than or equal to displacement, modulus of displacement. Okay. You check your notes. It is there. Distance is greater than or equal to displacement. When the body travels in a straight line, distance and displacement are equal. And if there is a deviation in path, you know, distance will be slightly greater. Okay. So moving on to question number 3 now. Question number 3. Read question number 3. Assertion. It is based on average speed and average velocity. Assertion. The average speed of an object is greater than or equal to magnitude of average velocity over a given interval of time. Okay. Average speed of an object is greater than or equal to average velocity. Next reason, the two are equal only if the path length is equal to magnitude of displacement. So you have to read the statements very carefully. The average speed of an object is greater than or equal to average velocity. We have written this. I told you, no, distance is greater than or equal to displacement. Look at that. Don't you remember? I've just done this now. distance is greater than or equal to displacement. When are they equal? When the body travels in a straight line, distance is equal to displacement. If there is a deviation in the path, okay, if there is a deviation in the path, who will be greater? Distance will be greater than displacement. And just imagine I divide with the time. So I must divide with the time here. Distance by time is called a speed. Greater than or equal to displacement by time is called velocity. We have written even this. Check your note. Speed is greater than or equal to velocity. Now let us read the assertion statement carefully. This is a very important question. Assertion statement. Read the assertion statement. The average speed of an object is greater than or equal to magnitude of average velocity over a given time interval. Yes, assertion is true. What about reason? Reason statement, the two are equal only if only if when are they equal? When distance is equal to displacement. When path length is equal to magnitude of displacement. When path length, that is distance, is equal to displacement. That is also true. And that is actually, this is trying to explain the first statement, right? Look at this. First statement, second statement says what? It's these two being equal, right? So actually second statement is trying to explain the first statement. So assertion is true, reason is true, and reason correctly explains assertion. Answer is option A. I'll do that one more time, then I'll ask you. Read the question very carefully. This is a very, very important question. Average speed of an object. Average speed of an object is greater than or equal to magnitude of average velocity in a given time interval. Okay, so what do we write now? We write the statement distance greater than or equal to displacement. All right, modulus of displacement. And we have learned, right? And then I divide with the time. When I divide left side with time, I should divide right side also with time. Distance by time is called speed. Displacement by time is called velocity. So speed is greater than or equal to velocity. Let us read the statement one more time. Assertion. The average speed of an object is greater than or equal to magnitude of average velocity. Yes, that statement is true. Assertion is true. What about reason? The two are equal. When are they equal? I told you when the body travels in a straight line. The two are equal only if the path length is equal to magnitude of displacement. The two are equal when distance and displacement are equal. So that is true. Reason is also true. And reason explains assertion, because assertion says about they being equal, right? And that is explained by the second statement. They are equal when first statement has an equal to here, right? And that is explained by the second statement. That is why I said reason statement correctly explains assertion. Is that clear? So this is how we do it. Look at this. Distance is greater than or equal to displacement. I divide by time. I divide the right side also with the time. So I get distance by time as speed, greater than or equal to displacement by time is velocity. Assertion statement says what? Speed is greater than or equal to velocity. That is true. Reason statement says what? They are equal when path length is equal to magnitude of displacement. That is also true. And that explains the part of assertion statement. Speed and these are equal, no? That is explained by this statement. So assertion statement is correct. Reason statement is correct. Reason explains assertion. All right. Now question number 3. Moving on to question number 3. Oh, question number 4. Instantaneous speed and instantaneous velocity. Read question number 4. Assertion. The average and instantaneous velocity have same value in uniform motion. Average and instantaneous. In uniform motion, velocity of an object increases uniformly. So I'll show this with an example. Read it. Assertion. The average and instantaneous velocities have same value in uniform motion. So I take a uniform motion. This is an example for uniform motion. 70 plus 2. I'm just giving one equation, no? And I tell you, okay, you have to blindly believe me. This is, I say it is uniform motion, okay? I say it is uniform motion. I'm going to find the average velocity. Okay. How do you find the average velocity? V average equation, do you remember? X2 minus X1 by T2 minus T1. I take a random sample. I'm going to find average between 0 second and 1 second. Okay, 0 second and 1 second. So tell me, what is X1? First value for time. 0 I can put. 7 into 0, 0 plus 2. That will be 2. X1 is equal to 2. And what about X2? X2 I can put 1 here, right? 1 in place of this. That is 7 into 1. 7 into 1 plus 2. That is equal to 7 plus 2, 9. Now I can find V average. V average is what? X2 minus X1 by T2 minus T1. That is X2 is 9. Look at that. X2 is 9 minus X1 is 2 by T2. Second time is 1 minus first time is 0. 9 minus 2 is 7. Answer is 7 meter per second. This is average velocity. Look at this. I'll repeat one more time. We have done many questions on this. It's a reader question, example question, frequently asked question in your school. Okay. It's very, very important. Average and instantaneous. Average, and we have done many questions. Textbook questions, I have done 2 questions in your class. All right. You know, textbook question itself. So V average, how do you find average velocity? Average velocity is given by X2 minus X1 by T2 minus T1. And I give you an example question. This is actually uniform motion, I presume. Okay. This is my suggestion for a uniform motion. Like I told you, you have to believe me here. Okay. And I say this is uniform motion, 7t plus 2. And then I'm finding average velocity. What is average velocity? X2 minus X1. Average velocity is X2 minus X1 by T2 minus T1. So first of all, X1 I can put. I take 2 times. No, this is T1, 0 second, T2, 1 second. And you know, if I put the first time 0 here, 7 into 0 plus 2. 7 into 0, 0, that is 2. Second time is 1. I put 1 here. 7 into 1, 7. 7 plus 2, 9. I got X2 and X1, so I can put them here. X2 minus X1 by T2 minus T1. That is 9 minus 2 divided by 1 minus 0. That is 7 by 1, 7 meter per second. How do you find instantaneous velocity? Hope you remember this. dx by dt I have to take. Dx by dt. All right. Derivative, no? That is how you find instantaneous velocity. Look at this. I take 1 by 1, 7. What is the differentiation of t raised to 1? 1 into t raised to 0 plus 2 is a constant. So differentiation 0. This is 7 meter per second. What did you understand? Average velocity is 7 meter per second. Instantaneous velocity is also 7 meter per second. So instantaneous and average are equal in a uniform motion. And that is valid. Okay, just imagine you're driving to Dubai in your car, and then you maintain the same speed throughout. Okay, it's a uniform motion. The moment you start until the moment you end, you know, you maintain the particular speed. What will be your average velocity? Same as velocity at any instant. Just imagine you are fixing your accelerator at say 140 km per hour. Okay, you have just entered the express highway. You're driving to Dubai, and then Doha to Dubai, you maintain this particular speed, 140 km per hour. Right? Your average will be what? 140 km per hour. And instantaneous will be what? Anytime. If you look at the speedometer, that will show 140 km per hour. So that's actually common sense. Instantaneous and average are same in uniform motion. Let us go to the statement and read it once more. So fourth statement, assertion. What is assertion? Tell me, what is assertion? Average and instantaneous velocities have same value in uniform motion. That is true. Assertion is true. How about reason? The two are equal. Oh, in uniform motion, velocity of an object increases uniformly. Is that correct? In uniform motion, does the velocity increase? In uniform, second statement, in uniform motion, the velocity of an object increases uniformly. Does it increase? No, velocity does not increase. So this is false. Assertion is true, reason is false. Answer is option C. So we have many options here, no? Did you understand this? So this is how you do it. What is the statement number 1? Assertion says what? The average and instantaneous velocities have same value in uniform motion. I have actually proved this with an example. I've taken a uniform motion I have found average velocity. I have found instantaneous velocity as well. And both are obtained to be 7. So that statement is true. Assertion statement is true. Assertion statement is true. Even otherwise, it's common sense, because if you maintain the same speed, your average will also be that same speed, right? So if you are in uniform motion, if you are driving your car at constant speed, the average speed and instantaneous speed at any instant will be the same. So that is what statement number 1 says. Statement number 2 is what? Reason. In uniform motion, velocity of an object increases. No. Uniform motion means velocity is constant. It doesn't increase. It doesn't decrease either. Uniform motion means uniform. Velocity is uniform. Velocity neither increases nor decreases. Velocity neither increases nor decreases. Such a motion is called uniform motion. All right. So let us look at question number 5 now. It is based on acceleration. 5, 6, 7, 8 are based on acceleration. Read it. Question number 5. Assertion. The acceleration of an object at a particular time is the slope of velocity time graph at the instant of time. Look at this. This is a velocity time graph. Okay. Velocity time graph. All right. Velocity time graph. It's an accelerated motion, right? It's an accelerated motion. So how do you find acceleration from this? I have given you 4 applications in class. Hope you remember. Number 1, based on xt graph. You don't remember, I have written this multiple times. These are very important things. Okay. I have an xt graph. This is position time graph. Okay. For which I have written 1 application. Slope of xt graph. Slope of xt graph is equal to what? That will be velocity. Slope of xt graph is velocity. Displacement time graph. Slope of displacement time graph. Slope of displacement time graph is velocity. This is displacement time graph. No? Displacement here, time here. Slope of displacement time graph is velocity. Slope of displacement time graph is velocity. All right. Then we have learned a couple of more graphs. We have velocity time graph. I don't know if you remember or not. If you take the slope here, look at the slope of VT graph. We have done multiple questions as well. Slope of VT graph is acceleration. Slope, you just draw a triangle and take theta, take tan theta. And draw a triangle, take theta, take tan theta. What you're getting is acceleration. Then area under the graph. It is actually displacement. And as an extreme level question, I even gave one more case. Acceleration time graph. Where do I draw? I draw it here. Okay. Hope it's okay. Acceleration time graph. If I take acceleration time graph, area under the graph is equal to change in velocity. Change. That's a previous ITGE question, but anyway, it's better if we can learn it as well. Change in velocity. Okay. So you have to write these applications you'll learn in our classes. Hope you remember all these. I can explain one more time. These are the applications of graphs. We have done this many times, right? First one, slope of xt graph. This is called xt graph, x-t. Xt graph means displacement time graph or position time graph. This is called displacement time graph or position time graph. Okay. And you may have one application here, slope of xt graph. Slope means what? Slope means tan theta. Tan theta from this graph is what? Tan theta from this graph is actually velocity. So this is application number 1. Slope of xt graph is velocity. Slope of xt graph is velocity. It's an xt graph. You find the slope, you are getting velocity. Then you have VT graph here. VT graph, velocity time graph. All right. Velocity time graph, you can find the slope. Slope. Again, tan theta. If you're finding tan theta, you're going to get what? Acceleration. Slope of VT graph is acceleration. Again, you're finding tan theta. Slope of VT graph is acceleration. And then area under the graph. If you find the area under the graph, what you're getting is displacement. Never ever forget these. And this is what? Acceleration time graph. Okay. For which, if you find the area under the graph, the shaded area, that will be change in velocity. You have to note this down. Did you finish writing this or take a screenshot? We haven't written this, at least take a screenshot. Have you done that? Or write as we do. Okay. As I write on the board, you have to copy it down, right? Or take a screenshot. All right. Do not keep things for later, okay? You will struggle a lot. That's what I want to tell you. Right. So question number 5 again. Acceleration of an object at a particular time is the slope of VT graph. You know, slope of VT graph. This is VT graph. Okay. Slope of VT graph is what? Slope is equal to, actually, we have written this already, acceleration. Slope is equal to acceleration. All right. So assertion statement is true. What does assertion statement say? The acceleration of an object at a particular time. Acceleration at a particular time. Acceleration at a particular time. Acceleration at a particular time. It's all given by the slope. Okay. Slope. All right. So reason statement. For uniform motion, acceleration is 0. For uniform motion, acceleration is 0. That is also true. Uniform motion, velocity does not change, does not increase or decrease. Velocity neither increases nor decreases. So reason is also true. But reason does not explain assertion. Reason has no relation to assertion. Are those statements related? No, they are independent statements. First statement says about, first statement speaks about what? The slope of VT graph being acceleration. Second statement is an independent one. They say what? Acceleration in uniform motion. Which question? For uniform motion, acceleration is 0. For uniform motion, acceleration is 0. That is right. But that is an independent statement. These are not related. So assertion is true. Reason is true. Reason does not explain assertion. So answer is option B. Did you understand? So read the statement again. Assertion statement. The acceleration of an object at a particular time is slope of velocity time graph. Yes, slope of velocity time graph. You draw a triangle, take theta, take tan theta, find slope. That will give you acceleration. So slope of VT graph is acceleration. Even if you have a VT graph like this is VT graph for a non-uniform accelerated motion. Okay. So even then, if you want to find, you draw a line there and draw x-axis, take theta, take tan theta. If you want to find the acceleration here, draw a tangent there, draw x-axis, find theta, take tan theta. Understood? So at any point, if you want to find the acceleration, you just want to take what? You're expected to take what? The slope, tan theta. Did you understand? This is for an accelerated motion I wrote. Uniform accelerated motion. No. What if it is non-uniform accelerated motion? Like this. Like this, acceleration itself is changing. Look at that. Okay, so for that, how do you find slope? Draw a tangent, then draw an x-axis there, then take theta, take tan theta. Again, slope will give you acceleration. Here, draw a tangent, draw x-axis, take theta, take tan theta. That's again slope. At this point, draw a tangent, draw x-axis, take theta, take tan theta. So at any point, if you take slope, what you're getting is acceleration. So assertion statement is true. Reason statement says what? For uniform motion, acceleration is 0. Yes, for uniform motion, acceleration is 0. Uniform motion itself means what? No acceleration. So assertion is true, reason is true, but reason has no relation to assertion. Reason does not explain assertion. Correct? Reason has no relation. They are independent statements. So assertion is true, reason is true, reason does not explain assertion. Answer is option B. Moving on to question number 6 now. Read question number 6 there. Assertion. Acceleration and velocity cannot change values abruptly at an instant. Yes. Acceleration and velocity cannot change abruptly. It is actually over a time. Acceleration keeps decreasing and then becomes 0. It can never become 0 all of a sudden. It cannot abruptly change. So assertion statement is true. That's a standard statement. Reason. The changes can either be continuous or discontinuous. You reason that is false. Change can be continuous or discontinuous. Change cannot be discontinuous. I told you, abrupt change is not possible. It can be continuously changing. Read it again. That's a slightly complicated statement anyway. If you read it again and again, you will understand. Assertion says what? Acceleration and velocity cannot change values abruptly at an instant. All right. All of a sudden, acceleration cannot come to 0. It actually decreases over a time. Read it again. Acceleration and velocity cannot change values. For example, you're driving the car. Think about velocity. You're driving the car at 40 meters per second. Okay. This is your car. Okay. And all of a sudden you apply brake and velocity decreases over some time. Okay, the car comes to stop over a distance, right? So velocity cannot abruptly become zero. That is true, right? Reason says what? The change, that means change in velocity or acceleration, can either be continuous or discontinuous. No. It has to be what? It has to be continuous. The change should be continuous. Discontinuous means at one point it is 5, next point it is 0. That is not possible, I said. No, abrupt change is never possible. So discontinuity is not possible. Their changes can be either continuous or discontinuous. The change has to be continuous. For example, if velocity is 40, it becomes 39, 38, 37, and it comes to 0. It is a continuous change. It is not like, at this instant is 40, the very next instant is 0. It is not possible. Do you understand? So assertion is true, reason is false, answer is option C. Did you understand? Look at question number 6. Assertion says what? Acceleration and velocity cannot change values abruptly. Yes, acceleration and velocity cannot change values abruptly. Yes, just imagine velocity. The car's velocity, your car is moving at 40 meters per second. Can it become 0 abruptly? No, it actually stops over some time. The velocity changes continuously, decreases continuously to become 0. Correct. So assertion statement is true. What do they say in assertion? Acceleration and velocity. I did with velocity. It is possible with acceleration also. At one point, acceleration is 5 meters per second square. At the next instant, can't be 0. Understood? It actually decreases to 0 over a time. So acceleration and velocity cannot change values abruptly at an instant. That statement is true. Then second statement says what? Their changes can either be continuous or discontinuous. Can this be discontinuous? No. It can't be discontinuous. Discontinuous means at one point it is 40, very next instant it is 0. Is that possible? No. I told you it has to gradually decrease. Continuous decrease should be there. They say it is discontinuous also, but that is wrong. So that is why I chosen false for reason statement. Now, the assertion is true, reason is false, answer is option C. Question number 7, assertion. For a particle, acceleration time graph gives velocity. Acceleration time graph gives velocity. For a particle, acceleration time graph gives velocity. Second is rate of change of velocity is acceleration. So let us see. For a particle, acceleration time graph. This is acceleration time graph, okay? Acceleration time graph. All right. Acceleration time graph gives velocity. All right. Let us see. Acceleration time graph, does it give velocity? Acceleration time graph actually gives change in velocity. All right. So that statement can be true because I told you if I take area of this graph, do you remember? Area of AT graph is equal to what? Change in velocity. Do you remember? Change in velocity. Correct. Oh, tell me what? Area of AT graph. Just take area under AT graph. Area under AT graph. We calculate area under AT graph. We wrote 4 applications. First one was slope of xt graph, velocity. Then slope of vt graph, acceleration. Area under vt graph, displacement. Area under AT graph, change in velocity. This is AT graph, right? Area under AT graph is what? Change in velocity, right? Change in velocity means final velocity minus initial velocity. If you know the initial velocity, you can easily find final velocity. Correct. So what does statements 1 say? For a particle, acceleration time graph gives velocity. So it is true. Reason. Rate of change of velocity is acceleration. Rate of change of velocity. Rate of change of velocity is acceleration. Yeah, that is true. But does it explain that statement? No, that is saying something about area. And this is saying rate of change. So they are independent. So assertion is true, reason is true, answer is option B. I'll explain one more time. Question number 7. Assertion. For a particle, acceleration time graph gives velocity. For a particle, acceleration time graph gives velocity. So I have drawn an acceleration time graph. We have seen applications. No, I told you, many times I told you, only 4 applications can be asked in any question paper, okay? Area under slope of xt graph, velocity. Slope of vt graph, acceleration. Slope of area under AT graph, change in velocity. Area under vt graph, change displacement. So area of AT graph is change in velocity, final velocity minus initial velocity. If you know the initial velocity, final velocity can be found out. You just put it here. Area you can put it here, right? Area you can find and put it here. Then take it left hand side, you'll get velocity. So what does the first statement say? For a particle, acceleration time graph gives velocity. That is true. Assertion is true. Reason is what? Acceleration is rate of change of velocity. Rate of change of velocity is acceleration. Rate of change of velocity means dv by dt. Rate of change dh by dt. Your height, variation of your height with respect to time. When you were in class 1, you were this tall, like 60 centimeters something. Now you are in class 11, you are like 1 meter 10 centimeters something. Understood? 110 120 centimeters. Okay. Or so you have actually changed your height over time. So you're finding change in height with respect to time. So rate of change actually is given by the term d by dt. So dv by dt is acceleration. So that is also true. But those statements are independent statements. First statement is about area of this or finding velocity. Second statement says something else. No? That has no relation to first statement. But that is true. Assertion is true, then reason is true, but reason has no relation to assertion. So reason does not explain assertion. Answer is option B. Hope you understood this now. Moving on to question number 8. The equation of motion can be applied only if acceleration is along the direction of velocity and is constant. Assertion statement. The equation of motion can be applied. Equation of motion is what? Equations of motion. V is equal to u plus at. S is equal to ut plus half at square. And v square minus u square is equal to 2as. These are together called equations of motion. Okay. And what do they say? These equations can be applied only if acceleration is along the direction of velocity and is constant. Acceleration is along the direction of velocity. Just imagine the ball is moving. Velocity is to the right. And there is a retardation. Retardation in the opposite direction. There also these equations will work. Correct. So if acceleration is against velocity, these equations can be applied. What about statement number 1 now? Assertion statement. What does it say? The equation of motion can be applied only if direction is along the direction of velocity. Is that correct? Only if along the direction. No. Even opposite. If it is retardation, no. Or just imagine a ball is going up. Acceleration is acting down. So even there, this equation is valid. So assertion statement is false. What about reason statement? If the acceleration of a body is 0, then the motion is known as uniform motion. Acceleration is 0, then the motion is known as uniform motion. Acceleration of a body is 0, then its motion is known as uniform motion. That's actually true. There is no such option given. I'll read one more time. Just give me a second. Let me just check the key they have given. They have gone wrong there. Okay. So I have to write it as option E. There you have to define a new option. Assertion is false. Reason is true. Mark option E for it. Okay. There is no such option, but I'm just defining a new option. All right. So read it one more time. Question number 8. Read it one more time. The equation of motion can be applied. The equation of motion can be applied only if acceleration is along the direction of velocity. Equation of motion can be applied only if acceleration is along velocity. Is that correct? No. Here the body is moving to the right. So velocity is to the right. And look at acceleration. It is retardation, okay, due to friction. It is in the opposite direction. So even there, this equation can be applied. Or take this case, a ball is thrown up. The ball is moving up. The velocity is upward. But acceleration is downward. So even if it is against velocity, acceleration is against velocity, these equations can be applied. So assertion is false. What does reason say? If acceleration is 0, then its motion is known as uniform motion. Acceleration is 0 means velocity is constant. So that is true. Assertion is false. Reason is true. Such an option is not given. So I am giving you another one, option E. Assertion is true, reason is true. Reason correctly explains assertion. Option A. Assertion is true, reason is true. Reason correct does not explain assertion. Option B. Assertion is true, reason is false. Option C. Both assertion and reason are false. Option D. I'm defining new one. Assertion is false, reason is true. They have made a mistake here. Okay. Question has a mistake. All right. So assertion is false here. Reason is true. Reason says what? If the acceleration of the body is zero, acceleration is zero means what? Definitely that is uniform motion because velocity is a constant. No other conditions, right? Acceleration is zero. Zero means what? The body can be at rest. But even then they have said motion is known as. So that is in motion, it is implied that motion is uniform motion. So assertion is false, reason is true. Such an option doesn't exist. So I call it option E. Is that clear now? Moving on to next part, kinematic equations for or kinematic equations for uniformly accelerated motion. Assertion says what? Position time graph of a body moving uniformly in a straight line is parallel to position axis. Position time graph, they talk about position time graph. X is on y axis, position time graph. Okay, this is position time graph. And what do they say? Position time graph of a body moving uniformly in straight line is parallel to position axis. Position axis, this parallel to position axis. Is that correct? Is that correct? Parallel to position axis. This is position, right? So its position at this time, at a particular time, look at the position at this, say this is 2 seconds. Okay, just imagine. Position 1, position 2, position 3, position 4. Is that correct? At the same time, different positions? Not possible. Not possible. Okay, so assertion is false. I'll explain it one more time. Don't worry. Reason, the position time of a non-uniform motion gives constant velocity at all instants of time. Position time graph in a non-uniform motion gives constant velocity. No, non-uniform means it is accelerated motion. So is the velocity constant? No, reason is also false. Assertion false, reason false. Answer is option D. I'll do that one more time. Question number 9. First question on kinematic equations for uniformly accelerated motion. First one, assertion says what? Position time graph of a body. Position time graph of a body moving uniformly in a straight line is parallel to position axis. So this is my position time graph. Position here, time here, position time graph. They talk about position time graph, right? And what do they say about it? The position time graph of a body moving in a straight line is parallel to position axis. Parallel, this is position axis. Parallel to position axis means this. Let us imagine this is 1 second, this is 2 seconds. At 2 seconds, look at the positions. You know, right here the position is 1, here the position is 2, position is 3, position is 4. So at the same second, the particle is at 1, the particle is at 2, the particle is at 3, the particle is at 4, the particle is at 5. At same instant, can the particle be at different positions? That is possible if the body can travel at infinite velocity. That is never going to be possible. Maximum velocity possible is velocity of light. So this is wrong. Okay, this is, we have drawn this graph in class. We have taken the slope there, tan 90 is infinity. No particle can have different positions at same time. So assertion is false. What about reason? The position time graph in a non-uniform motion. Position time graph in a non-uniform motion. This is position time graph in a non-uniform motion, accelerated motion. No, gives constant velocity at all instants of time. No, wrong. At this point, draw the tangent, draw x-axis theta. At this point, draw the tangent, draw x-axis theta. Look at theta. What happened to theta? Theta increases as we go up. So tan theta increases, velocity increases. Is velocity constant? No. That is false. Read it again. The position time graph. Position time graph in a non-uniform motion gives constant velocity at all time. No, constant velocity is not constant velocity. Here you draw the tangent. Here you draw the tangent. Here you draw x-axis. Here you draw x-axis. Take theta. As you can see, theta keeps increasing. So velocity also increases. Assertion is false. Reason is false. Answer is option D. Did you understand? I'll revise this question one more time. We were on question number 9. The position time graph for a body moving uniformly in a straight line is parallel to position axis. Parallel to position axis. Position axis is this. Parallel to position axis means at the same time, different positions. Such a thing is never possible. So assertion is false. Reason says position time graph in non-uniform motion. Non-uniform motion gives constant velocity. No, no, no. At this point, we have one velocity tan theta. At another point, we have yet another value for tan theta. Right? It keeps changing like that. Understood? Hope it is clear. Now moving on to question number 10. Question number 10. Question number 10. Doubling the initial velocity. Very, very important question. Doubling the initial velocity. Stopping distance of moving object increases by a factor of 4 for the same deceleration. Stopping distance is proportional to square of the initial velocity. Read it. Doubling the initial velocity. Stopping distance of a moving object. Look at this. What is stopping distance? I'll tell you. Look at this. Just imagine a ball is moving. A ball is moving with a velocity u. After traveling a distance, the ball comes to rest. That means velocity becomes 0 over a distance s. Okay. So what do we have here? The body. We have a ball rolling on the ground. The ball moving with a velocity u, and then it comes to rest. That means velocity is 0 over a distance s. I can apply the third equation of motion. Whenever something is stopped, this equation has to be used. For example, a bullet is being stopped. A ball rolling on the ground is stopped. A ball moving on the ground is stopped. A car moving on a road is stopped. Right. V square minus u square is equal to 2as. Stopped means final velocity 0. So I can put 0 square is minus u square is equal to 2 into a into s. So I can cut 0 square, no? What is stopping distance then? It is minus u square by 2a. This is the equation for stopping distance. All right. Stopping distance. And then minus is not required because it is retardation. The car is stopped. That is why you saw a minus sign there. Okay. And they say about increasing the initial velocity. The car, just imagine we had a car here, no, a small car, and the car was coming at, say, the car was coming at a speed of u, and the car came to rest. Car came to rest over here. Okay. Right. Right. So just imagine the car was coming with, say, n times the velocity. So what will be the new s? N times, no? This 2 will be same, a will be same because tire and the rod, they remain the same, no? So a will be same, deceleration will be same. Only thing that changes is u becomes nu the whole square. Nu the whole square. Nu means what? N square u square by 2a. So if I take u square by 2a, that is all s. So n square times s. So s dash is n square times s. That means if the initial velocity is increased to n times, stopping distance becomes n square times. I'll explain this one more time. Look at this. This is called stopping distance problem. It's a frequently asked question, okay? But I didn't take this in this chapter because this is coming up again in work energy power. Okay, there is a reader question here. It's a frequently asked question in NEET examinations also. Stopping distance problem. Stopping distance. From the name itself, it is clear. Stopping distance. Distance required for stopping. All right. So this is a car coming with a velocity u. Its initial velocity is u. Finally, the car is stopped over a distance s. So its final velocity is 0. So I write down my equation v square minus u square is equal to 2as. All right. So 0 square. Finally, the car is stopped. So final velocity is 0 square minus initial velocity is u square is equal to 2a. Yes. So I get s from this. What is s? 2a comes to denominator. There was a minus sign, but forget about it. It is because it is retardation. The car is stopped. So this is the equation for finding stopping distance. And they say something about increasing the velocity. Tell me what? When you increase the velocity to n times, the car was coming at double the velocity, 2u, triple the velocity, 3u, 4 times the velocity, 4u, 100 times the velocity, 100u, n times the velocity, nu. So common sense, no? So in place of u, I put nu. The car was coming at n times the current velocity. nu divided by 2 is the same, a is the same. Why retardation same? Why is retardation same? Because same tire, same rod. So same friction. Same friction is causing retardation. Same tires, right? Same rod. If you increase the speed, will the tire change? No. Will the road change? No. So friction remains the same. So A won't change, 2 won't change. Only thing that changes is nu, u to nu. Nu the whole square, which is n square u square by 2a. Tell me u square by 2a is old s. So nu s is equal to n square times old s. Let's go back to question number 10 now. During doubling the initial velocity, stopping distance of moving object increases by a factor of 4. Doubling the initial velocity. Doubling means what? Doubling means this n is 2. Doubling means n is 2. N is 2. So 2 square times s. That means 4 times s. Yes, stopping distance becomes 4 times. Read it again. Doubling the initial velocity. That means if the initial velocity is doubled, stopping distance increases by a factor of 4. Yes, stopping distance becomes 4 times. That's true. So assertion statement is true. Let us read the reason statement. Stopping distance is proportional to square of initial velocity. Stopping distance is proportional to square of initial velocity. Yes, that's also true. And actually that is why we have this, right? It is because of this statement that the first statement comes. So assertion is true, reason is true, reason correctly explains assertion. Answer is option A. Did you understand? So this is how the stopping distance equation goes. Stopping distance is given by u square divided by 2a, where u is the initial velocity of the body and a is the retardation. You can find the stopping distance there. And if the body's velocity was n times u, it changes to what? The new stopping distance will be n square times s. N square times. If it is 2, 2 square times. 3, 3 square times. 9, 9 square times. 10, 10 square times. Okay, in assertion statement, what does it say? Doubling the initial velocity. Doubling the initial velocity means n is equal to 2. Doubled means 2. So this is 2 square. 2 square into s. 2 square is 4. 4 into s. So when velocity is doubled, stopping distance is made 4 times. So if the car is coming at a velocity, say it stops in 10 meters. If the car is coming at double velocity, it stops in 40 meters, 4 times. Stopping distance will be 4 times as much as in the first case. That is true. Assertion is true. Reason is what? Stopping distance is directly proportional to square of initial velocity. Look at this. Stopping distance is directly proportional to square of initial velocity. That is also true. And this statement actually justifies the first statement, because it is because they are proportional that it becomes 4 times, right? Right. Why does the first statement stay? Why does the first statement come? How does the first statement come? First statement says it is. First statement says it is. Tell me what? First statement says it is 4 times. That actually comes from where? Because it is proportional to u square. So assertion is true. Reason is also true. And reason correctly explains assertion. Answer is option A. Is that clearly understood now? So for this question number 10 is very important. Doubling the initial velocity. That means when initial velocity is doubled, stopping distance becomes 4 times. That's true. Assertion is true. Yes. When it is doubled, it becomes 2 square times, 4 times. When it is triple, 3 square times, 9 times. When it is made 4 times, 4 square times, 16 times. When it is made n times, n square times. Assertion is true. Reason says that stopping distance is proportional to u square. Stopping distance is proportional to u square. That is true. And it is because of that it becomes n square times. So assertion is true, reason is true. Reason and assertion are interconnected. So answer is option A. Question number 11, assertion. Kinematic equations are exact and always correct. Kinematic equations are exact and always correct. No, they are not exact and always correct. They are correct under certain conditions only. Kinematic equations, no? Kinematic equations are exact and correct. They are not exact and correct. That's a standard statement. And then the definitions of instantaneous velocity and acceleration are true. only for a motion in which magnitude and direction of acceleration are constant. No, that is valid. That is exact and are always correct. Second statement is always correct. So that is also false. Answer is option D. I'll repeat one more time. Read the question. Kinematic equations are exact and always correct. They are not exact and always correct. Kinematic equations. V is equal to U plus AT. S equal to UT plus half AT square. Kinematic equations, you know what? Equations. Those equations are not exact and always correct. They are not. They are exact and correct under certain conditions only. Okay. So they are not. That's a given statement, typical statement. Okay. So assertion is false. Reason. Definitions of instantaneous velocity and acceleration are true only for motion in which magnitude and direction of acceleration are constant during motion. That's also wrong. Definition of instantaneous velocity and acceleration are valid for any kind of motion. Okay, so that is also false. Assertion is false, reason is false, answer is option D. Did you understand? So read that statement again. Question number 11. Assertion. Kinematic equations are exact and are always correct. No, kinematic equations are not correct always. Kinematic equations are not exact and always correct. That's a standard statement you have to learn. That is, these equations, kinematic equations are what? V is equal to U plus AT, S equal to UT plus half AT square, V square minus U square is equal to 2AS. Those equations are correct and exact only under certain conditions. They say what? Kinematic equations are exact and are always correct. That is false. They are not always correct. Then reason. The definitions of instantaneous velocity and acceleration. Instantaneous velocity is velocity at a particular instant. And instantaneous acceleration is acceleration at a particular instant. And those definitions are valid for any time. What do they say? Are true only for motion in which the magnitude and direction of acceleration are constant. So they say definitions of instantaneous velocity and acceleration are valid only for certain cases. That is wrong. They are exact and are true for all the time. So reason is also false. Assertion is false, reason is false, answer is option D. Is that clear now? Question number 12. Velocity time graph. Assertion statement first, then reason. Velocity time graph for an object in uniform motion along a straight path is straight line parallel to time axis. Velocity time graph for an object in uniform motion. Velocity time graph for an object in uniform motion is what? Velocity is a constant. Uniform motion, right? Velocity, uniform motion. Do you remember the graphs? Uniform motion. All right, no issues. Okay, so question number 12, velocity time graph for an object in uniform motion along a straight path is a straight line parallel to time axis. Yep, that's right. Assertion is true. What about reason? In uniform motion, an object velocity increases as square of time elapsed. Uniform motion velocity increases. Is that correct? No. Hint is given in bracket. Uniform motion velocity is a constant. So assertion is true. Reason is false. Answer is option C. I'll explain that one more time. Read it again. Question number 12. Velocity time graph. Velocity time graph for an object in uniform motion. Uniform motion means velocity is constant. Do you remember? You are entering an express highway and your dad is maintaining a particular speed. That is called uniform motion. For uniform motion, you know, you have drawn the graph. Same velocity. So graph is a horizontal straight line. Okay. For a uniform motion, the graph is a horizontal straight line. Horizontal straight line. All right. And then what? Straight path is. So read the statement, assertion statement. Velocity time graph for an object in uniform motion along a straight path is a straight line parallel to time axis. Straight line, yes. Straight line parallel to time axis. Yes, assertion is true. Reason. In uniform motion of an object, velocity increases as square of time elapsed. Velocity increases as time square of time. Velocity increases. Does velocity increase? No. Velocity is a constant for uniform motion. Assertion is true. Reason is false. Answer is option C. Did you understand now? So for question number 12, I told you for question number 12, velocity time graph is A straight line parallel to time axis. That's right. Uniform motion, right? So assertion statement is true. Reason says in uniform motion, velocity increases, but velocity never increases. Velocity is a constant. So reason statement is false. Assertion is true, reason is false. Answer is option C. We are moving to the last question here. Relative velocity, based on relative velocity. The relative velocity between any two bodies moving in opposite directions is equal to sum of velocities of two bodies. Relative velocity when moving in opposite direction, how do you take velocity? Relative velocity is VA minus VB, vector VA minus vector VB. I don't know whether this is still taken in your school syllabus, but just in case, this is how you take relative velocity. Relative velocity of A with respect to B is taken as VA minus VB. Now here they take what? Relative velocity between any two bodies moving in opposite directions. So opposite direction means you have to write what? VA minus VB. Opposite means minus. So it is VA plus VB. Right. So VAB, relative velocity is VA plus VB. So assertion statement says what? The relative velocity between any two bodies moving in opposite directions is equal to sum of the velocities. Assertion is true. And reason is what? Sometimes relative velocity between two bodies is equal to difference in velocities. Yes. Difference. When difference? When they are moving in same direction. Right? So that is also true. Assertion is true. Reason is true. And reason justifies assertion also. When they are in same direction, you take difference. So answer is option A. Did you understand? Answer is option A for this. I'm asking the whole class, tell me, did you understand? So the last question is about relative velocity. Relative velocity is velocity measured by a moving observer. Okay, moving observer. When you are also moving, when you say a car's velocity is 60 km/h, it means you are at rest. But what if you are also moving? In that case, you will find relative velocity. This is how relative velocity is defined. VA minus VB, vector VA minus vector VB. And what if they are moving in opposite directions? Opposite direction means VA minus VB is taken. They are in opposite direction. No, minus or minus is plus. So VA plus VB. That is what they say in first statement. Assertion says what? When two bodies are moving in opposite directions, relative velocity is sum of the velocities. Yes, sum of the velocities. So assertion is true. What about reason? Reason statement says what? Reason statement says what? Reason, sometimes relative velocity between two bodies is equal to difference of velocities of two bodies. Yes, velocity, difference. Sometimes that can be difference also. Difference, no? So reason is also true. Because difference is taken when they are in same direction. Sum is taken when they are in opposite direction. Difference is taken when they are in same direction. All right. So actually, second statement comes from first statement. You have taken difference there, no? So assertion is true. Reason is true. Reason correctly explains assertion. Answer is option A. So we have completed first paper of assertion reason discussions on straight line motion. In the next session, we'll be doing laws of motion, if it's okay for you. Or if you have any suggestion, you can send me. Shall we wind up for the day?